Hello, everybody, and welcome to my presentation of the Festive Tech Calendar. We're going to be going over minimal APIs and making a Santa's to-do list API. So, a little bit about myself. Go ahead and start this. I'm Alec Harrison. I'm a Lunavi software consultant. Really big Azure nerd. I love helping people out to get to learn the cloud. It's kind of one of my big passions. Want to make it seem as least scary as humanly possible. And I want to help teach people how to use the cloud, how to feel comfortable using the cloud, and preferably how to save money while doing it as well. So if you want to go, I have some Azure Cloud Workshops. That's also where this talk will be documented at Azure Cloud Workshop organization on GitHub. We have a few things out there like a serverless architecture, building your first CI/CD pipeline, and then this talk as well for minimal APIs. And it'll also go a little more in depth on how to deploy those to Azure Container Apps. I'm also a co-organizer of the Iowa Microsoft Azure User Group, hosted the Midwest Global AI Conference. And if you have any questions, feel free to email me or Slack me if I'm in a plethora of Slacks, or just shoot me a message on LinkedIn. I'm just Alec Harrison. Feel free to connect me, follow me, shoot me a message, whatever. If you just want to talk about Azure stuff, want to learn about anything, or Lunavi is also hiring. So if you're looking for a job too, just let me know. We can work something out. So I gotta have a question for everybody to start this off with. Who really enjoys excessive boilerplate in APIs? I remember the first time I started in software development in college, we did a Java class, and it was like public static void main, then you would do your code and blah, blah, blah. And then one kid, I think the first day of class was like, what is all that other junk? Don't worry about it. That's like a 300 level class. This is like Java 101. We're not going to talk about that. We're years away from even discussing like what that means, or call stacks, or we're just teaching you how to print to the console. So I personally believe that minimal APIs kind of came from the exact opposite of that. How do we give people as little as humanly possible and still able to help them satisfy their needs? I believe in C#6, we've noticed a trend of Microsoft trying to make it like as beginner friendly as humanly possible. Let's get rid of all the extra using directives we don't need. Let's start including core libraries. Let's get rid of a lot of that boilerplate that maybe after a few years you know what it means, but when you're going to get started, it's just another thing to scare you away from programming. So I believe that's kind of the vein that all of these juices were flowing when people started bringing up minimal APIs. So to start with this project, we're going to go ahead and start a Visual Studio. You'll notice a Visual Studio Code instance. You'll notice everything's empty here, so we're going to be starting from scratch, and this should be something you can follow along with. I'll also have the entire walkthrough posted as well, so we can kind of go from there. The minimum requirements you'll need to get this started is you're going to need .NET 7. There's a bunch of new things in .NET 7 that kind of, I think, in my opinion, makes minimal APIs a real feasible tool that you could use not only to learn, but also potentially suggest in a production environment if you're wanting to, get out something quickly, have as little stuff there as possible, hosting functions, hosting containers, all that sort of fun jazz that maybe you don't want to go the full path of entire .NET app. The other thing you'll have to do is trust the .NET Dev certs if you haven't done that before. If you haven't, it'll pop up when you create this. But for the very first thing, we're going to do a .NET new, and we're going to do a web in my output, and I'm going to call it a minimal API. So if we start with that, I'm going to drink while we're doing that. What did that do? So that created a project for us. It is very, very bare bones. It just has our auto-compiled OBJ, our properties, app settings, which is also very empty, an almost empty CS proj, and our program file. And if you look at here, if you're more familiar with .NET, like 3-ish time frame, you have your program.cs, which eventually calls a startup.cs, and that's kind of where all your core stuff lives. As of, I believe, .NET 6, they've moved to a process where Basically, you can do everything you need to do in startup, but it's going to be a single sourced file in just your program CS. So what you're seeing here is a web application that'll be built. We'll use app builder, the app builder. And then also this is defining an endpoint at the root, so slash hello world, and it'll run. So if you're using Visual Studio as well, you can use all the cool tools there to run this. If you're not in Visual Studio, oh, let me get in the right directory, sorry. If you're not in Visual Studio, you can use CLI commands like this as well. So we're gonna do a .NET run for our project. I could have also passed in the path, but all I did was change into the directory my project's in. So if I look, my project is gonna be live at port 5144. And doesn't that just roll off the tongue? Doesn't it just, let me get my Chrome open here. And we'll see here, it says hello world. Great, we're done. Minimum APIs, cool. Well, if you're gonna go and use this in a real world scenario, you probably wanna know a little bit more than just, hey, I can say hello world, cool. So we'll dig a little deeper into this. The first thing we're gonna want, personally, when I work with .NET APIs, I really like the entity framework. So that's your ORM to be able to talk to a database. The other thing we're going to do is, because this is a sample app and something that we're not going to, really persist, you can if you want, we're going to use EF core in memory. So that means basically that we just aren't going to have a real SQL server running behind the scenes. It'll do it all in memory and it'll clean itself up when the app dies. So we're going to start by adding that package, and it would help if I use the right. All right, so we're going to do .NET add package. And I'm going to copy and paste the package names just so I don't fat finger something. So this is going to be Microsoft.entityFramework core.inmemory. So this is the package to do all of our stuff in memory. This is going to allow us to have some state in our app while it is running. The other thing we're going to want to add is diagnostics for Entity Framework. And finally, we're going to want to add swashbuckle so we can get some .NET Swagger code gen stuff to work as well. All right, so this app will let us run and get going. We're able to see today already we can get our APIs going. We can have a URL. So if you're familiar with the standard .NET API, typically they like to be in ports. I believe it's 5000 and 5001. I could be totally wrong there. And they tend to give you an HTTP and HTTPS, so you can test both protected and not. So just for the sake of argument, if you want to do that, you can go ahead and do that with right here under our app, do an app.urls.add. And this is telling our .NET application what port or what URL we want it to run on. So this is going to be my HTTP port. And I'm going to have a port. Nope, not just S. Port 1. All right, so now if I do .NET run, if you remember up above, it said it was running on that weird port. I think it was 5144. And we're still in C#. Minimal APIs, but we still need semicolons. Thank you, compiler. Oh, and it looks like I might have something already running on that port. So go ahead and make sure I have that all done. And let's try that one more time. Sweet. Now we have our 2 ports that we specified up above. And if I go to 5001, I again get my hello world, and we go back to that other URL. Nothing can be found because it's not there anymore. Awesome. So the next thing we're probably going to want to do is we're going to add our Swagger endpoints. So this is going to give us our cool Swagger UI to be able to hit our stuff and not have to look at that one screen. So the first thing we're going to do is add our first using, which is our Microsoft Open API models. And then we're going to add the Endpoints API Explorer and Swagger CodeGen. So we'll do that after the builder here. So we're going to do builder. And if you look at these in any application you currently have, these will be familiar. You're just typically using the iService instead of just getting it from your builder. So a lot of these things, if you're trying to convert or migrate to a .NET minimal API or migrate to a only program.cs for the future, you are able to just kind of go with the flow and use what you already have. And we are going to for the future's sake, we're also going to add, we'll just start with that. Sorry. Add Swagger CodeGen, and we need to give it the description. So we're going to do just a name here for the config. Dot Swagger dot, oh nope, not what we wanted. We'll just call it v1, new open API info, title, and we'll call it Santa API. Give it a description. Every good kid gets a gift. Version, again, we're going to do v1. And we'll go ahead and semicolon that. And let's do a little bit of cleanup there. So now if I go to run this, let's make sure I didn't fat finger anything, which was totally possible. Oh, sorry, I totally forgot. Now down here we want to do app.useSwagger and then app.useSwagger UI. And that's going to be c.swagger endpoint is going to be at /swagger /v1/swagger JSON. And it will be the Santa API v1. And it looks like we missed a semicolon. Sorry, looks like there's a minor issue here. Use Swagger config. Let me make sure I didn't fat finger any of this. Looks like I might have. Oh, yep, it looks like I fat fingered services. And sorry about that. We'll go ahead and click here. And I'm going to go to /swagger index.html, and boom, here's all the information we just put out there. And I can actually test my endpoints here, and I can get my hello world to work. Hello world, sweet. So what's next? Well, in an application now we have this, we want to start creating some actual models to return. So how do we do that? We're going to go ahead and create a folder here called models. And this is going to be similar if you've used EF Core before. You're going to need your models, and then you're also going to need your DB context. So we'll do models. And the first thing I'm going to do is create a DB context, which will be my Santa DB context.cs. And that's going to go ahead and we're going to grab our two usings, which is a minimal API and EF Core. So this is just going to grab for all of our other models. And then we're going to create two other objects that we're going to reference here, but we'll go ahead and start with this. So we're going to do class Santa. Man, I really cannot type today. I apologize. DB context, and that will extend DB context. And we're going to do a public, build our constructor. It's going to be DB context options, and DB context options. And we're going to have the base. This will be an empty constructor. And then we're going to, because it's EF Core, have to declare the models we want to use. So we're going to have a DB set for a child. And plural is going to be children. And then get our get and set methods. And then we're going to do a public DB set for gift. So every child is going to obviously want gifts for Christmas. So we're going to go ahead and get that going. And we need some semicolons. Now it's not going to have any reference to a child. So I'm going to do a new file and do child.cs. And we'll go ahead and copy, or we'll go ahead and give it a namespace. Minimal API.models. And it's going to be public class child. And for this model, every child is going to have a ID by default. That's just so we can get an update by ID. Pretty good standard practice. They'll have a string, which will be their name. A bool is good. A bool for checked twice, because everybody knows Santa has a list and he will check it twice. So just because a child is good doesn't mean they'll get a gift unless they've been checked again. And then we're also going to have a virtual foreign key on a gift, which will be the wanted item that the child wants. So we got to know the item so we can give it to the elves and let them know the child was good and that it was ready to be built in the workshop. And then we're going to have a ready for delivery, just so we know at the end of the day when a child has a present, the child object can then tell us it's ready for delivery so that we know that child is good to go. All right, and then we're going to need a gift model that gift model, we're also going to throw in the same namespace here, and that'll be minimal API.models. If you're doing this in Visual Studio, a lot of the stuff comes for free. So we're going to have a public int as well. That's going to be, again, the ID. So if we, for some reason, have the gift's unique ID, we can update it. It's also how it's going to connect through our foreign key behind the scenes in the database. We're going to do a get set. So we're going to have a name of the gift, and then we're going to have 3 bools, and I'm going to just copy and paste those for the sake of time. We're going to have should be built. So as soon as a child has been marked good twice, their item will be marked as should be built. We're going to have started building, so that'll take this item off the queue for the L's so they know somebody else has already started building it, so we don't build it multiple times. And then we'll have is completed, which the child's gift will be marked as is completed, and then it'll also mark the parent element as is completed as well, so we're good to go there. So the first thing we're going to want to do, now that we're back here, is we're going to have to add our DB context to our program.cs. So what we're going to do is copy and paste this. Just make sure I don't fat finger anything. We're going to do a builder, add DB context, the Santa DB context we just created. And we're going to make sure that we need to link the models as a using up here. We're also going to need to add EF core so that we know when to use it. And then just for a quick endpoint, we're going to want to be able to post something. So let's make sure that this still compiles first before we get too far down. And it does not. Semicolon, 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 semicolon. Where are we missing it? Oh, are we not supposed to have one here? That might be the issue. Got a little too semicolon happy. There we go. Awesome. So we're still running. Let's go back to program CS. So let's create our first endpoint. So we have our dummy endpoint here. That's just the hello world one. Let's create our first one that can be what Santa's going to use. So we're going to want a get. So we're going to do an app.map get, and it's going to be /child. It'll be an async operation. And we're going to want one thing here as a parameter. We're going to want Santa's DB context, which we're going to call DB. Arrow await, and we're going to do DB dot children, because that was the plural name we did. And then we're going to include the wanted gifts objects. So that means every time we get all the children, we're also going to see all the gifts they want as well. All right, and then the other thing we're going to want is to be able to create a child. So that'll be app.map.post, sorry, not dot post. And we're going to do /child async, and we're going to have Santa DB context. And then because this is a post, we are going to be getting a child object as well. And that one's going to be a little longer, so we're going to do await db.children add async await db.save changes async. Oh. And then we're going to return typed results dot created. We're going to use this to get child, not capitalized, child ID to give the created identifier, and we're going to return the child object. Perfect. So now, if we run this, we can go ahead and pull up Chrome, wherever it went, and we don't want to cancel our recording. We now have get children and create children. So let's go ahead and do a get just to prove that the in-memory database is working. And it's returning nothing because we haven't created anything yet. So let's go ahead and post a child. There'll be the default values here. We don't really care at the moment what that all looks like, but it's going to return a 201. It's going to return back the object if we go all the way down right here. And if we come up here and re-execute our get, we'll see, hey, we have something at ID 1, and it's all the default values. And it does have a gift as well, or a wanted item. Cool. So the other things we're going to want to do here is, I'm going to skip ahead a little. We're going to want a thing for Santa to check it twice. So if a child is good, we want Santa to be able to update that. And then we also want to do a quick check to see if they were already marked good. We want to make sure that we mark them as checked twice. So we're going to do a put. Let's be at /child. And then we're going to pass in a bool for is good and the ID of the child. That way we can easily find it in our database. Semicolon, and we're going to do var child equals await db.children.where, and I'm going to do x.id equals the ID I'm passing in, and I'm also going to include do a dot include, the wanted items. So the reason we're going to include the wanted items is because if a child is good twice, so checked off the second time, first or default async, we're going to want to change the child object, the foreign keyed object of wanted item to mark it down as it should be built, so an elf can see that and work on it. So the normal things here, if child is null, so that means we couldn't find the child, somebody gave us bad data. We're going to return a results.notFound. So that'll be for any IDs we don't currently have in our database. And then we're going to have some logic here. If child that we found is good already and is good was passed in as truthy, that means they were good and then the Boolean was passed in as true, the child.checked twice is going to be set to true, and then child.wanted item should be built is going to be set to true. So this is a child who was already good, we checked, so we're going to say they were good twice, now their thing deserves to be built. Else, we're going to set child.isGood equal to isGood. So this is assuming that a child can never go back from being is good twice and marked good and everything is being built. So in the second case, if the child was not already previously marked as is good, we'll just set it to whatever the is good value is. So that could be a child who was good, marked bad, a child who was bad, marked bad again, because we're assuming that a child that was good twice will never be marked back. But again, that's just this fun little scenario. Await, and because we are already tracking those entities, we can just do save changes async on the database, and then we can return results.no content. All right, and now we have kind of the API built for Santa. To save some time and not go over the tediousness of this, we'll kind of just copy and paste what we have for the ELF API. So as an ELF, now that this API is built, I need an endpoint to tell me all the ones that need to be built. So what that's going to do is, minimize that. I'm going to get any of them at gifts/needing built. I'm going to grab all the gifts where should be built is true and started building is false. So once something is started building, it'll be taken off this list in queue here. I'm going to create an endpoint that is a put so that we can update and mark something that it was started to be built, which is this one. We're doing the same process as up above. We're going to try to get the gift by ID. If we don't get it because it's not found, we'll return not found. Otherwise, we'll update it to true. Since we're already tracking the entity, we can just do save changes and we'll return no content. And finally, this is the biggest one I think of them all, and this is the one that everybody is probably most excited for. If a gift is already built, it can be finished. So we'll pass in the ID again. The gift to update, we'll try to find it. Again, if it's not found, we'll do that. We'll try to find the child that the gift is also linked to. If it is a childless gift, we'll again return a not found. If we can find both of those things, we're going to mark the gift, which is the sub element, as being completed. And then we're going to also set the parent element as present ready for delivery to true. Again, since we're already tracking those entities in EF Core, we'll save those changes and we'll return no content. So what does that look like in practice? We'll go ahead and show the API here real quick. Oh. It looks like I may have gotten a little copy paste happy. On line 37. Oh, I did not get copy paste happy. I just didn't finish my thoughts. All right, so now when I go ahead and pull up this API and I give this bad boy a refresh, you're gonna see we have a bunch more endpoints. So let's first post a child. So the default stuff is always just at index 1 because, again, we killed the app and started it again. You'll notice that in memory, we only have a child at 1. So, again, it cleaned up its state. So what we're going to want to do is try it out. And we're going to set is good to true. It's going to be for ID. Well, let's just, for the sake of this, to prove the other case works, true for 99. We got back a 404 because that child doesn't exist. But if we set it to true, that child is good. Do it again. The child is definitely marked as super good. So now if we do this, needing built, we can execute this and we should get response of at least 1. And yeah. Should be built is true. Oh, and this, sorry, this is just an issue with the data I mocked. Everything just defaults to true, so it auto created a wanted item as should be started being built. So let's create another child real quick. So everything was marked to true, so when the child needing to be built, it it marked that as true. So nothing was showing up on needing to be built because it was already done according to our fake data. So we'll go ahead and do this. Make sure we go in here, create this. Should give us a 201. Now if we go through and say needing to be built, we'll see, hey, we got one thing back. It's item 2. It needs to be built. So we can go in here, update item 2 to mark it as needing built. 204 was updated. And then we'll say item 2 is finished. And then if we get back all of the children again, we'll see it was marked as finished. So at a very high level, now we have a simple API. Well, I think the first thing that I always ask, or at least somebody in security always asks, is, okay, that's great. What's stopping in this scenario a rotten kid from going in and changing their list? Just like changing their grades or whatever, or a disgruntled elf from marking every kid as bad or every item is done. Or an elf that maybe is a little too full of himself and wants to take Santa's job and just mark every kid as naughty to get out of doing work and building stuff. So what we're going to do is we're going to add authentication and authorization. This is huge for this in particular, the .NET 7, because you can actually start doing authentication and authorization and testing things locally super slick. So we'll go ahead and add that in a similar fashion that you would. So we're going to first add our 2 using statements, and to make sure I don't fat finger that, we're going to add authentication with JWT bearer. So that's how Azure AD will use auth. Just for context, this won't be set in as of right now to do Azure AD out of the box, but it'll be pretty close, so it shouldn't be a big change from there. And then just want to tell it to use authentication. So the first thing we're going to want to do is change our add Swagger code gen definition a little bit, because today the Swagger will not be set up to accept a bearer token. So what we changed is just added a security definition. So it'll be a JWT auth header using bearer. It's going to be authentication. We're telling it that the parameter location is in the header, be it API key, and the schema is bearer. The other thing we're going to want to do is add cores and add authentication. JWT authentication, which will happen right after this. So these are pretty much just right out of the box. And finally, we're going to want to add authorization. So authorization is kind of where it gets fun, where you can start, I guess, as fun as security can be. And then you can just add your own roles. So this is kind of where you have the opinion or the options to do what you want to do. So for this particular API, I think we're going to want at least 2 roles. We're going to want an options, and they're called policies. So we're going to add a policy. And it's going to be the require Santa role. And then it's an arrow function. Policy dot. And you can do a bunch of things here with this. We're going to just do the required role. So that means that we're going to be expecting a role in our JWT token that is Santa role. You can do things like scopes. You can do a lot of other things here, validating where it comes from, all that sort of stuff. But just for this simple example, we're going to say, if you have the role, we'll let you in. If not, we're not going to. And for the same reason that we want a Santa role, we're going to also want an elf role. Policy.required role, elf role. All right, we got our policies. So the next thing we're going to do is we're going to need to start locking down our API endpoints. So, oh, and I did also forget, we're going to want to Make sure the app is using authentication authorizations. We'll throw that bad boy in. All that in at the bottom. And now we need to start locking down stuff. So what does that look like? Well, it's really a lot easier than you would think. So we're going to go through, let's keep hello world there, but every other endpoint we're going to want to add our particular roles to. So required authorization Santa for that one, Santa for that one, and I believe this is the last Santa one. And we're going to do the same thing for the elf endpoints. Go ahead, require role for that, require role for that, and finally require role for that. So what is that doing? That behind the scenes is saying we need to get a JWT bearer. We might have missed a using statement. No, doesn't look like it. Let me double check. Sure we didn't forget anything. Add authorization, add options, add cores, require authorization. Where does it say JWT bearer? We might have fat fingered something. Gotcha, I think I missed this. Yep. Missed installing that. So and I probably fat fingered something else, so we'll go through that real quick. It's not candidate for add policy, so let me make sure I didn't fat finger that bad boy. And there we go. All right, demos are always flawless and never have any issues. So our hello world still works as expected. So now what's going to happen is, if you notice here, we have this so we can throw in an API key. But if I go to hit a child endpoint, one that we locked down to Santa, it's going to give me a 401 and tell me that I need to have a bearer token. So before this, being able to test this locally was kind of a pain. What you had to do is you had to go in, change or create a user account in Azure or some sort of JWT identity provider. In Azure, specifically Azure AD, sometimes it'd take 10, 15, 30 minutes, for that to take effect. It just became really monotonous and kind of a pain to test. But luckily, we're going to go ahead and keep this app running. They created a new way to test all of this locally, which is really sweet. So what you can do is you can create a role locally. Let's quick prove that the curl doesn't work. Locally. And it's going to be like this. We're going to do a curl I-H authorization bearer, and we're just going to say ASDF, so that's obviously not a valid bearer token, end quote, and it's going to be hitting https://localhost 5001, and let's do the child endpoint. You'll see I am unauthorized. So in order to fix that, what I can do is I can use this nifty tool called user JWTs create. So we can do a .NET user JWTs create, and I can actually give it a role that I want to create a real token with a specific role. So that will have the Santa role. Again, need to make sure I'm in the right file. And what does that token look like? Well, if we actually decompile it in something like jwt.io, we'll see here's the audiences. We're not validating them. We could, but here's the Santa role that we are expecting to see. So now if I go to use this token in my curl command here, instead of just doing ASDF, maybe. Go back, paste that there, hit it, and we got a, oh, why did we get signature key now? Signature key not found. Make sure that everything's set up correctly. Looks like we got require Santa role, require authorization. Oops. Let's try this one more time. Oh, you know what? I probably got some white space. All right, let's try this again. Well, interesting. Signature key was not found. That's interesting. This has worked before. Let's see what I can do here real quick. Yeah, it's telling me it's generating one with an invalid signature too. Huh. Weird. Oh, maybe it's because I need to define a scope as well. That is the command, right? Weird. This is a new one for me. So technically, this should all work, and it should tell you that you're. Let me just double check something real quick. Go ahead and pause the